Module 5. If you got it last time, no need. Okay, let's start. We talk about port numbers, right? Port numbers, when do we create the port numbers? The time we establish the connection, right? When we establish the connection, we decide source port and the destination port, right? And source numbers are useful to whom? To the receiver. When we receive something, we want to know which application that data should go to. So we look at the destination port number and direct to appropriate application. So port numbers are used both TCP and UDP. That's the only thing common between TCP and UDP. Port numbers keep track different conversation crossing at the network at the same time. Okay, so we look at, and then we look at different kind of port numbers. There are 3 different kind of port numbers: well-known port numbers, registered port, and the dynamic port. UDP has less overhead. Overhead means keep track of 12. So we look at IP. You guys are lazy, don't want to get up at 9 o'clock. So this is one year sit here. Okay, alright. So far, so good. Okay, you go there. Guys, okay, sit here. Okay, alright. So far, so good. Okay, you go there. Guys, okay. Anyway, hopefully no one else comes today. Alright. Is that clear? IP is unreliable. What does it mean? No keep track, right? But that doesn't mean that we lost the data. What we discussed, but we learned something special. What is this? IPv4 address has 2 parts. And then this device, this PC, we don't call a PC or device as address, but she is coming. Anyone is there? She is coming. Anyone here? Okay, sorry, I didn't see you. Sorry, I didn't see you. Yeah, so fell down thing, right? Anyone here? Friend is coming. Okay, so come. You take one of this and then sit somewhere. Can you take this one? Or this one, whatever you like. This one is lighter. Put it somewhere. Yeah, whatever. Okay. Put it somewhere. Okay. Yes. So you can move a little bit and then you can okay. Guys, don't be lazy. Get up at 9 o'clock. Okay. If you are registered in 9 o'clock class, please come to 9 o'clock one, right? Okay. Alright. Okay. N.H. What's the rule? What is the rule for N.H? What's the rule? We discussed this slide, correct? So what's the rule? Yes. Everybody in the same broadcast domain should have the same end part. Remember, everybody in the same broadcast domain, should have the same end part. Can we change it? No, it's a rule. Different broadcast domain means different end. Is that right? Different broadcast domain means different end. That we have seen. And then we look at a common practice. We can change it. What is it? What's a common practice? First H given to the router interface. 1.1, 2.1, 3.1 given to the router interface. That's a common practice. We can change it, right? Then we look at this diagram. Remember? And we give IP addresses everywhere necessary. And then we have 1.1, 1.2, 1.3, 2.1, 2.2, 2.3, 3.1, 3.2, 4.1, 4.2, 4.3, 5.1, 5.2, 5.2. Right? Understand? So we did that. Correct? Okay. Now I add something here extra. What is it? I give the interface. This is E0, this is E1, this is H0. Please copy guys. Okay? This is E0, this is E1, this is H0, this is H0, T0, and E1. Okay. Can you guys switch a little bit? Okay. Can you guys switch a little bit? And then one of you guys. You can sit here. Okay, one of you guys can sit here, and there are some outside, something like this. Could you please go and get it? I'm sorry about that. Please. You know, I waste a lot of my time here. Don't do that next time, please. Okay? If you are registered to the morning 9 o'clock class, please come at 9. Okay? Okay. So everybody clear in this diagram? Everybody clear this diagram? Yes or no? Yes, correct. We did it last time. Only thing I add was. Okay. Can you guys squeeze a little bit? Let me help you. No. Yeah. Okay. Fine. All right. Okay. All right. Can't you make it? You can make it sit down, right? Sit down. Okay. Okay. All right. Fine. This is okay, right? Yes. Come. Sit there. It's okay. It's all right. Yes. All right. I got it. But I think best thing what I should do is check whether students register for the section 1 or section 2. It takes a long time. So I don't know whether who's coming in section 1 or section 2. That's another issue. Anyway, let's see. Please guys, be considerate of others. That's all we can do, okay? Be considerate of others. That's important. Okay, please. Otherwise, you know that our class disrupt, pace goes, because I have to cover everything what I covered in the previous section today ideally. So guys, please be considerate of everyone. Okay, I'm trying to accommodate as much as possible. And I don't want to check, I don't want my teacher to come here and check whether you guys registered in this section or that section and comment on, okay? Okay. Now, how many routers we have here? 2 routers, router A and router B. Switches maintain a table called switching table. What kind of things you see in the switching table? MAC address and the port. Similarly, routers maintain a table called routing table. What kind of things you see in the routing table? What do you see? Routing table, IP address and the interface. Can you guys complete the routing table of router A now? Please complete the routing table of router A. We have IP address and then interface. Do it now, guys, quickly. Do it only for A, don't do it for B. Okay, I'll tell you why don't do it for B. Please do it for A. Okay, please do it for A. Routing table of router A. Okay, how many interface we have for router A? How many interface? 3. What are those? E0, E1 and S0. E0, sit there. Sit there. Yeah, sorry about it. Okay, yes. E0, E1 and S0. Okay, right. 3 interface. So can you guys complete the table now? The similar way that we complete the similar way we complete which table? Similar way we complete the one here, one over there. Similar way we complete the switching table here. Complete the routing table. Complete the routing table. Fine, guys. How many entries altogether? How many entries altogether, guys? How many entries? Okay, what's the first one? Tell me what's the first one? What's the first one? What's the first IP address? What's the first one? 1.1, which interface? Is 0. What else? 1.2, which interface? Again, 1.2 is 2, is 0, right? And then, Faidila, guys, 1.3, which interface? Is 0, and what else? 2.1, which interface? E1 and 2.2, which interface? E1 and what else? 2.3, which interface? E1 and 3.1, which interface? S0. All right. So this is the routing table of router. Routing table of router A. Many entries, correct? How many entries altogether? 7. Okay, 7 entries. Easy, right? Similar way that we have look at the switching table, right? Same way that we look at switching table. All right. Okay. Now, look at here. I have a question for you guys. Look at this diagram. This diagram. We have a router. Everybody listen to me. We have a router with how many interface? 24 interface. Each interface, every interface connect to a switch. That means 24 switch, right? And each switch has how many interface? 24. Each interface of each switch connect to a hub. Hub has 24 interface. Each interface of hub connect to a PC. Okay. What is the size of router A's routing table? Do you understand my question? What is the size of router A's routing table? Is there any other vacant seats? Could you please get some chair from outside here and sit somewhere? Look at here, guys. I think if this continue like this way, I have no choice but ask my TA to come and check the sections because it's very difficult. I mean, it's inconvenient to if that particular student register for this section and if one of you guys register for the previous section, it's not fair, right? So next time, be considerate of others. You need to get no chairs. You need to get a chair from outside somewhere, please. Okay, and put it somewhere. Okay, so please be considerate of others. So, like otherwise things become very unpleasant to all of us. Okay, please. Okay. How many entries is the router routing table now? How many entries? How many entries? Every PC has to have a entry, right? So how many PCs altogether? Simple mathematics. Can you do that? Okay, don't bother. It should be very large, very large. But having a very large routing table doesn't help. So we need to find solution. The solution is we don't keep n.h. We don't keep the IP address in the routing table. We convert h to 0, and once we convert h to 0, we call it as what? Network address. Instead of having IP address in the routing table, we don't keep the IP address. We keep we don't keep n.h. We keep n.0. We keep only the network address, correct? So that means we change it. Now how many entries, guys? Now how many entries? How many entries? Now, based on how many? N.0 means what? How many broadcast domains? How many broadcast domains here now? 24 only, understand? So very large becomes very small to 24, right? Similarly, we don't keep the IP address in the routing table. We keep only the network address in the routing table. So we change to what? Network address. We change it. Okay, so that is what we have in the routing table. Can you change your routing table of router A? Please, network address. Okay, how many broadcast domains router A has? How many broadcast domain router A has? 3. So which ones? What are which networks? 1.0, 2.0 and 3.0, right? There are 3 broadcast domains. So we have 1.0, 2.0 and 3.0. 1.0 connect to which interface? 1.0 to which interface? E0, right? And then 2.0 connect to E1 and 3.0 connect to S0. Alright guys. Similarly, how about router B? We have network address and the interface. How many are there? 4. Router B, tell me which ones? Yes, 3.0 connect to which interface? 3.0 connect to S0. What else? 4.0 connect to E0 and 5.0 connect to E1. Okay. So this is what we call initial routing table of router A. Initial routing table of router A, right? So now look at here. What kind of things are available here? Router A is what? Now look at here. Look at here, everybody. Please stop your work. Router A has connect this 1.0 connected, right? 2.0 is connected. 3.0 is connected. We call it as one. Directly connected right now. We call what? Router learns routes directly connect to the PC, right? So this is a directly connected. A 1, 2, 3 is directly connected to A, and 3, 4, 5 is directly connected. Now let's see the communication between PC1 won't send a message to PC3, okay? PC1 to PC3, IP address, source and destination. Okay, what source IP? Who's the source? PC1, what's IP address? 1.2. And then destination IP address is PC3, what is it? 2. So we have this communication goes to the, okay, I don't write the MAC address because look at the routers, look at the mostly IP address, correct? So I just skip the MAC address, but MAC address has to be there. So now what happens? It comes to the router, so it passed the PC2, right? PC2 make a copy and what? Discard, right? And it goes to the router, what router does? When this comes to router, what router does? Coming ones and zeros. Can we check the router table looking at ones and zeros? What is the first thing to do? The encapsulation up to which layer? Network layer. Router do up to network layer, switches do up to the data link layer, remember? So we do the de-encapsulation, router do the de-encapsulation up to the network layer. Is that right? And then what can we see? We can see the source and destination IP address, right? So we look at the destination IP address. Destination IP address, correct? So what is the destination? 2.2. Okay, now let's change a little bit. First day I come to Hong Kong. Sorry, first week of in Hong Kong. As soon as I come Hong Kong, my friend of mine gave me a car so that I can move around. And my girlfriend is coming to see me. She's coming to the airport. I should go to the airport to pick up. So I'm driving, first time driving in Hong Kong. I go out of UST and go to the, I go to a roundabout. UST roundabout is not called Choi Yong roundabout, okay? I go to Choi Yong roundabout, and roundabout is something like a router, correct? Router has different paths to go out, roundabout also different exit, right? I want to go to airport. When I'm reaching airport, I've never been there. How can I find the path? I'm approaching to a roundabout. I'm not sure which exit to go to the airport. How can I make that judgment? Sorry? Of course, when I'm approaching the roundabout, there is a big board, right? Written there, exit 1 to Mongkok. Exit 2, I can see a plain sight, right? What does it mean? I should take the exit 2, right? And then go to the next roundabout, again look for the airport side, and take the third exit, for example. I go like that. Similarly, when it comes to the router has something, what is it? Router has a board. What is the board? Routing table, exactly. Router has a routing table, something like we are approaching to a roundabout when you drive. So, which exit to be taken is depending on what is available in the table, right? Understand? So now guys, destination is 2.2, correct? Do I know where 2.2 is? What router knows is what is available in the routing table, right? So are we looking at the entire IP address? We look at which part? End part. So we look at only the end part of IP address. What's the end part? 2. Do I know where 2 is? I'm router A. Do I know where 2 is? Yes, I refer to my routing table. Do I have it? Yes. What's the decision? What's the decision? Forward to where? E0, right? I make a decision to forward. So it comes to router A. I decide this packet to be forward to, sorry. I check whether you guys got it correct. Okay, it should be Siwantai. Okay, should be. You guys didn't correct me. Look, you guys came late, totally distract me, so my concentration goes everywhere. Okay, E1. So what we do? We send the packet out of, look at here guys. Can router send directly to PC2, PC3? Cannot, right? Router cannot send direct to PC3. Is that right? Excuse me, you need to get a chair from outside. I'm sorry. There is no empty chairs here, okay? Could you please get one? I'm sorry, and can you guys squeeze a little bit so that you can sit there? I'm sorry. Okay, now look at here. Can router send the packet to PC3? No, router send out from the exit, right? Correct. So what router does is simply send the data out of E1, correct? So data goes through the media, is that right? So what happened? Who's the first one to see? PC4, right? What PC4 does? PC4 make a copy and discard. So now look at here. What router look at which part of the IP address? Network. Look at here. Network ID, network part enables a router to put the packet into the appropriate network segment. Now which segment we send? Come from E0 and send to E1, appropriate network segment. That decision made by looking at the end part. Is that right? Look at the end part of the IP address compared to the routing table. Understand? So the network part helps router to put the packet into appropriate interface. Okay. Now guys, everybody in E1 has the same end part, right? Now how can I decide whether to PC4 or PC3? How to decide? Which part do we need to look at now? H part, right? H part is 2 means my destination, correct? So to deliver the packet to specific host, now we need which part? Now we need H part. Guys, look at next one. Could you please delete the router? Delete the router here, please. Just type a mistake in the lecture notes. Delete the router. Delete this one. Now host ID helps to deliver the packet to a specific host. Now we have two hosts, PC5, PC6. Which host? Sorry, PC3 and PC4. Which one we should send the data? Now we look at the which part? PC3 or PC4. We look at the H part too. Is that right? Understand? So N part look at by the router to put into appropriate network segment, and H part is help us to deliver to a specific host. Is that clear? Understand, guys? So router maintain routing table. So next communication, can you guys do it by yourself? PC1 to PC5. PC1 send a message to PC5. Can you guys do it by yourself? PC1 to PC5. The previous one is PC1 to PC3, right? Could you please do it from PC1 to PC5? PC1 to PC5. It's not okay. Okay, what's IP? PC1, what is it? 1.2 destination IP? Sorry? PC5, what is it? 4 point? Okay. Go to where first? Which router receives the packet first? Router A. What's the decision? What is the decision router going to make? What? Forward to where? What's the destination address? 4 point? So do I look at the entire destination address? We need only which part? End part. What's the end part? Does router A knows where end part is? Does router A knows where the end part is? What router knows is what is available in the routing table. Can you see 4 is in the routing table, by the way? Can you see 4 in the routing table? Router A. Can you see it there? So what's the decision? Simple what? Discard, right? Simple discard. We can't communicate, right? But of course, this is not good, right? Not good. So we have to find solution. Now look at here. Router A and router B are neighbors. What the neighbors always do? What the neighbors always do? What the neighbors always do? Gossip, not communicate. They always gossip, right? Understand what is gossip means? What does gossiping mean? What does gossiping mean? Chit chat. Chit chat means what they do? Do you know what happened there? Do you know what happened there? What they do? Exchange what they know each other, right? Understand? They router A and B are neighbors. They always gossip. Okay. So what router A will tell B what router A knows, correct? Router B will tell A what is B knows, correct? So what kind of things A knows? What A knows means what is available in the A's routing table. What B knows means what's available in the B's routing table. What kind of things in the A's routing table? Which network? 1, 2 and 3. B's table is what? 3. Can they exchange? Yes, they can exchange. How they can exchange? They are a bit far away. We need a messenger, right? We need a messenger to carry the information from one router to another router. Messenger is something I mentioned to you. Who's the messenger? Messenger is the one who helps routers to build the routing table. I mentioned the name before. What is that? Helps routers to build the routing table. I mentioned it. What is it? Routing protocol. Have I mentioned that? Yes. Routing protocol is the messenger. Routing protocol. So what happened is B send a message to A, right? With the help from routing protocol, right? So what kind of information B informed to A? Whatever B knows, correct? What are which networks? 3.0, 4.0 and 5.0, is that right? Understand? We will inform to A about what B knows. Right? Can A learn something now? Yes or no? Which kind of things A learn? 3 is already there. Which one can learn? 4 and 5. Yes. So we can learn 4 and 5 now. Okay. So we can learn about network 4.0, network 5.0. What should be the interface for 4.0? What's the interface? Okay, 1.0 interface is A0, right? That means, guys, look at here, guys, please again. From router to go to 1.0 interface should be E0, right? From router to go to 2.0 interface should be E1. From router A to go to 4.0, what should be the interface? Interface should be S0, right? So we should go from S0. So this is S0, and 5.0 is also. Okay. Similarly, can B also learn something? A also send a message to B, right? Which networks? Network 1, 2, and 3, and then we can complete the B routing table as well. Okay. So now can we communicate? Can PC1 send a message to PC5 now? Yes or no? Yes. So what we do? We need to have 4. Is it available now? Is it available? Yes, 4 is available to go to S0, right? And then we send the data out S0. What happened? It goes to router. It goes router B. Router B that do the D encapsulation, right? And look at the destination address is again 4.04. Is it available? Now we refer to which routing table? Router B. Now we are in the B, right? We refer to the router B's routing table. Is it available? Yes. What's the decision? Forward to E0. Then we send the data to E0. PC5 will receive the message. Okay. Understand? So every router. So basically, neighboring routers exchange the information. Which information they exchange? Information available. Whatever information they know, right? Information they know means what is available in the routing table. So they exchange the information, and who helps to exchange the information? Who helps to exchange information? Routing protocol. Routing protocol helps routers to build the routing table, complete routing table. And then we can that's it. Now let's continue. PC1 to PC5. Look at here, guys, again. Please concentrate. PC1 to PC5. First go to which router? Which code router? First go to router A, right? Once we are go to router A, before go to PC5, what we need to do? We need to jump to B, right? When we are A, first jump B and to PC5. When we are A, router B, we call it as what? Next hop router. What is my immediate next? What is my immediate next hop? Okay, understand? So when I'm A, immediate next hop is next hop router. Alright, guys, now look at here, this diagram. We want to communicate from PC1 to PC2, right? And when we communicate from PC1 to PC2, which router will come first? A. When I am in A, what's the next hop? B. When I am in B, what's the next hop? C. When I am C, what's the next hop? D, and no more next hop. Next hop means what is my I may go to many routers, but next hop means what is my next immediate. Okay? Next hop means what is my immediate next hop. Okay, that's called next hop router. And can you guys understand these two slides? Sorry, these two bullets. Please read these two and see whether you can understand it. Guys, if you don't have the module 5 notes, I have some copies here, okay? Module 5, if you don't have the notes, please come and collect it. I have some copies here. What is this one says? What is this bullet point says? Sorry? Yes, everybody in the same broadcast domain. Everybody connects same router interface should have the same endpoint, right? What the second one says? What the second one says? What is the second bullet point says? Please. N.0, right? We don't keep the IP address, but we keep the network address N.0. So by doing so, we can scale down, right? We can have a smaller routing table. We can scale down. We don't keep the IP address. We keep the which address? Network address. By doing so, we can have a smaller size of the routing table. Okay. Okay. Can you remember? My girlfriend in US need to find me. Which address used? My logical or physical? Logical, right? So logical address can be used when you are very far away to find the path, right? Logical address means which address? IP address. So IP address has which significant? Global significant. No matter where we are, we can use the IP address global significant. My physical address is Percy. When can we use it? After coming to the ISOM department, correct? So that means which significant? Local significant. That's MAC address. Physical address has a local significant. IP address has hierarchy, but MAC address is a flat address. Okay. All right. Now next thing, what we're going to discuss is the different classes of IP address. Okay. So how many classes we have altogether? A, B, C, and class D and E. Altogether, how many classes? 5. Class D is for what? Class D for multicast. Remember multicast? Sending a message to a group. And class E for? Class E for? So, remember, if you want to give address to any of these interface, we should pick one. A or B or C. So, any address to be given to any interface, PC, router, anything, or computer, laptop, your mobile phone, everything, we should have a class A or B or C. Alright guys, let's have a 2 minutes break and then we'll continue. Okay. Let's see what is ABC means. 2 minutes break. And please talk to me if you have any questions. And if you don't have module 5 notes, we have module 5 notes here. Please come and collect it. Okay. Any questions? Any questions, guys? Yes. 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 So that's why. So if the destination is not available in the table, we have discard. So that means before we discard it, we should learn more. So learning others happen very fast. Yes, correct. Anything else? Yes. Okay, it depends on how do we design the network. And if it's a very large scale, of course, we have solutions for default, which I will explain to you. That means without discarding. Take, of course, for example, 4.0. We look for 4.0. Simple thing is this. You send a message from this PC to your friend in US. Your friend's network can it's possible to have it in a USB router, or in other words, USB routers can have every network in the world. So what we need to do is we should send our ISP. Yes. So we should have a mechanism in every router. If it is not available in the table, please send to ISP. Then ISP will send to another ISP. That's how it goes. You understand what I'm saying here? So there's a special entry in the routing table which I will explain to you later. Called default route. Default route means any address not available will do accordingly.
Yes, but
do you understand what I'm saying here?
I get that part.
Yes.
I don't know what you're Sexy man, big lover, full of energy. Gasoline and pressure, woman, going fashion, running like a panther, power run the street. Right, you must drive tonight for love. Win, you must win tonight. Idol forever, speed man, speed man, speed man. jump all around me. I got feeling, I got steaming. Go, 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 go. Gotta keep on moving, baby. I
rather than discarding, we do what is what say. Okay, so in this case, very large network. I'm probably not 65 or 56. So Windows size is 2 means we are sending 10 as much as okay. I told you, but there are two parts of the idea. And then edge, correct? So do you know which one is N, which one is edge? Don't know. That's what we are going to learn.
喂，東浩。
Alan 搞掂咗。
唔係啊，我就係因為負1我先咩嘅。如果你得嘅話，你頂一頂我啊。
有負1咩依家？
我唔玩就負1咯。
咁唔得啦，你要機型。
係咯，咁我就嚟要交啦嗰份嘢。
幾時交啊？
今晚咯。
你爭幾多啊？
我而家仲打緊個好數嘅，一開頭左右啫。東浩你安啦。
唔緊要啊，喂 Stereo 個 lecture video 停咗喺度，佢即時睇佢嗰個 stream， 唔知做乜撚嘢。
係喎，佢開咗 stream。
你哋周到佢冇？你哋周到佢唔係睇緊。
唔係周到佢唔係喺電腦面前，唔知做緊乜嘢。
係喎，應該出咗廳。
打電話俾佢，打電話俾 Alvin， 喂。
Alvin AFK 嘅。
哦，你安啦。我做完我會玩嘅。
但係得我 Herman。
唔係啊，呢度有 Anthony， 有 Elsie， 有阿 Ken， 就係爭東浩你。除非你有個比我更加強嘅藉口咧。
頭先，喂 Elsie， 我嚟督促你噶，做乜停個 lecture video 唔睇啊？快啲睇翻！做乜停個 lecture video 唔睇啊？快啲翻去台面睇翻！ 如果唔係就機翼或者打機，你揀啦。你想請食機翼定打機？唔係，依家一筆還一筆，唔係叫你睇一出 video，係你依家離開咗個位，咁你要有啲懲罰。個懲罰一係就機翼，一係就打長路先繼續睇。咁而家勒令你啊，一係就掀開隻杖啊，一係就棄裝備啊，你自己揀。勒令一係打長路，一係就機翼。咩？等陣先啫，你啲等陣先好耐。拜拜。有時聽到我話佢個 lecture video 停咗，即刻靚貓，即刻大嗌靚貓。
Telecommunication and Computer Networking Management 有 XD 啊！喂，你啲有 lecture video 呢個真係個神物嚟嘅，我真覺得。
係咯，我都想喎，睇翻佢。
都好想講讀三個 course 都有，即係叫我冇翻學啫。
叫啦，直接唔翻學都得啦。Homeschooling 啊，
其實科大一定要有，科大冇都好難生存。你冇可能上堂聽得明，同埋你冇可能上得齊堂。
係咯，兩樣我都覺得。
我第二個先係重點，其實。
咁我覺得呢樣嘢係佢必須做嘅，即係我覺得學校。
佢既然有佢嘅問題啦，即係呢個係可以幫助學生學習嘅嘢。
係咯。係咯，我係咁樣認同，即係如果你講到自己啲 course 咁好，係咪？少少叮當啊，拍下片擺翻上去都做唔到，唉！科技大學喎，科技呢？
啱喎，科技大學一定有啲科技噶嘛。
啲科技呢？啲科技垃圾。
笑咗。
蘋果切開後點解變色？氧化咯，唔係咩？
係啊，跟住然之後，
因為
鋼琴8級，
因為爛咗，
個嘢爛咗，
嘅嘢爛咗，
因為啲鐵氧化。有冇學生答？因為佢曬黑咗。
因為佢曬黑咗。
本身咧切開未曬到，切開咗曬黑咗。
麥東豪唔係頂 Losa 咩？
係啦，東豪頂我啦。
我頂，我都諗住睇 lecture video 嘅，睇咗20分鐘，見到老丁話打機啦喂，諗住講句睇 lecture video 啦喂，點知就真係變咗打機啦喂。從6點鐘你哋收皮，我就瞓着咗。啱啱先瞓醒，食完個公仔麵，攞個 lecture video 送麵，我先可以堅持到睇到20分鐘。
屌啦！我上堂唔好講笑，上3個鐘，聽5分鐘都瞓着啊！真係。
一定啊！一開頭諗住俾心機聽，一講嘢嗰刻我就想瞓。
聽日有 midterm， 但係完全冇嗰種危機感。聽日考晏晝4點，諗住聽朝先瞓。
係咪？
啱啊，算啦。
仲有4份嘢星期2要交，我諗住聽日先做。
唉，好。攞部手機睇下 PowerPoint， 好似咁樣個感覺好啲，冇咁罪疚。
係啊，我都覺得，我都中意㗎。會整一整，雖然到最尾係咪成日睇係另一回事。
喂 ，Swan 啊！
呢科我要話我做本多中性，
你玩本多中性咯。
本多中性攻速型，啪啪啪啪啪，完全攻速，
全攻速 J4 拍死人可以。
啪啪啪啪啪，即係可以玩本多中性。我揾唔到一隻咧，又本多即係攻擊個樣差唔多，係 J4 遲少少。
屌！ 玩 K 連先，睇有幾避。
Any IP version for address given to you guys? Which one is N? Which one is?
希望可以繼
Now we are
續
going to look
贏
at the
落
definition.
去。
I said that there are how many classes? How many classes?
高勁啲啊
A, B, C, Class D, and Class
我唔知彈射
Class
係
E
咩，但
for
係
which
我玩
purpose?
單雙排係多經驗值。
Multiclass, correct? Class E for
咁咪下場試下。
research. So if I want to give IP address to anywhere, if I want to give IP address to anywhere, I should use by which part? Either Class A or Class B or Class C.
今日
Okay, we have to use one of
因
these
為有
classes.
剪容，好
A
有
or B or
喎
C. Class D has a special meaning.
連
Class
贏
C
唔
has
長。
And I want to tell you something again here. Every department has a special committee. University Provost Office asks every department to have their own SSLC. SSLC stands for Student Staff Liaison Committee. Okay, so it's easy for you guys to join to be one of the SSLC members for BBIS program, which is easy, and you can write in your CV easily. Okay, you can write in your CV. Very simple thing is, you guys come and have a, and you can write in your AOBO. Class D has a special meaning. Class D. And I want to tell you something again here. Every department has a special committee.
都要填。
University Provost Office asks every department to have their own SSLC. SSLC stands for Student Staff Liaison Committee. Okay, so it's easy for you guys to join to be one of the SSLC members for BBIS program, which is easy, and you can write in your CV easily. Okay, you can write in your CV. Very simple thing is, you guys come and have a free lunch with me on 7th of November, 12 p.m. Please come and have lunch. The main idea of
安娜4級咯。
and you can SSLC stand for Student Staff Liaison Committee. Okay, so it's easy for you guys to join to be one of the SSLC members for BBIS program, which is easy, and you can write in your CV easily. Okay, you can write in your CV. Very simple thing
咩仲會
is,
似
you guys come and have a free lunch with me
冇
on
啲純將佢揸劍
7th
一
of
揭
November,
嗰陣會
12 p.m.
啪嘅聲
Please come and have lunch.
飛上去。
The main idea of
如果九頭有光速 Q 嘅話，咪可以本多中星。瘋狂 Q 就啪啪啪啪啪啪。其實 K 連真係好似槍神咯，個攻擊方法。而家我未買 Chrome 碼添 K 連，
粉紅色咯。
冇買 Chrome 碼。以榮耀等級5，守衞98。睇下幾廢先 K 連。又有牙叔同傑㗎啦，一定係。
都真係有好多牙叔。
場場都有。